All right, welcome to the first Algebra 2 lesson. So, this Algebra 2 lesson will be brought to you in part by Party Dog Wrapping Paper. Now, going into this lesson, we're going to be covering lesson 8-6, okay? So, get that lesson open, get it ready, and I'm going to go over some notes that you should be familiar with prior to starting this lesson. I basically broke down what you need to know in order to do each problem on this lesson and in your practice. So as I go over this, yes, my handwriting is awful. Yes, my pen smears a little bit. You guys have to deal with it. So let's start. Before we get into the natural logs, ln, I want you guys to know that most rules for the normal logs that we covered a while back are all still valid. So the first one was adding can turn into multiplication, subtracting can turn into division, and exponents can go out front and become big, and just like that, backwards and forward, so the big letters can also go in and become exponents. So the same thing we covered with logarithms a couple weeks ago are all still true for natural logs as well. So again, if you have these that are adding, you can multiply them, subtracting, you can divide them, make sure you do it in order, and then the exponents can come in and out as they please. All right. Another thing that you guys should know going into this lesson is remembering that fraction exponents can turn into radicals. So here's an example. I use this example specifically because you will see it in this lesson. But x to the 1/4 can turn into the 4th root of x to the 1st power. So the rule of thumb here is numerator goes on the inside, denominator goes on the outside. So I wrote that 1 in here. If it is a 1, we don't necessarily need to do it, but if it's any other number, we actually have to write it, and we have to apply it if it is a number. So if it was like 3 squared or something, we would have to actually multiply that out. So again, numerator of the fraction goes in, denominator of the fraction goes out, and you should be good to go. Now, another thing we're going to need to know is how do we get rid of ln, or the natural log. So again, think opposites here. So what's the opposite of addition? Subtraction. The opposite of multiplication? Division. The opposite of ln is going to be e. So to cancel out ln, we use e. So if we need to get rid of ln, we apply e to both sides. What does that mean? Well, here's an example for you. Okay, ln of x equals 3. Solve for x. Apply e to both sides. So notice it pops into the exponent portion. And then e will cancel out ln, and x is all by itself. Now e cubed, or e to any number, you can just type into your calculator and you get a decimal. So I did it here. You can test it to make sure you get it that matches, okay? So just keep that in mind. Again, this is the notes. You can revert back to it anytime to kind of see what we're doing. Now, key note here. This works backwards as well. So in problems number 7, 8, and 9, you have e first, and you apply ln to get rid of e. So you'll see that when we hit those 3 problems, but just know it goes forward and backwards. Just like the opposite of addition, subtraction, and subtraction can kill addition. The opposite of ln is e, and the opposite of e is ln. So they're kind of inverse functions of each other. So keep that in mind, and let's go on to question number 1. So question number 1 is 5 ln 2 minus ln 4. So before we can start attacking the subtraction sign, we need to get rid of this number that's out front. So what do? We take it and we apply it as an exponent. So we should get ln 2 to the 5th minus ln 4. Now, since this is a number raised to a number exponent, we have to actually do the arithmetic here. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Yes, my beautiful hand. So 2 to the 5th is 32. So this is just ln of 32 minus ln of 4. Now we can do our subtraction rules. So again, what's the rule for subtraction? We can divide it, make sure the first number goes on top and the second number goes on bottom. So we would have ln of 32 over 4. Now, can we simplify that fraction? Yes. How many times does 4 go into 32? It goes into it 8 times. 8 times 4 is 32. So this is ln of 8. Now that's all it wanted for your answer. Could we type this in and get a decimal and type it into the calculator and get an actual decimal answer? Yes. But for this purpose, we just needed to simplify. Now, moving on to number 2. Same thing, even easier because we're dealing with letters that we don't have to simplify. So, step 1, take this number and get rid of it first. So we're going to apply it right there. It's the exponent. And we're going to get ln x cubed plus ln y. Now you should be having deja vu to our last log lessons, right? So again, it's pretty much the same stuff, except now you're dealing with natural log. So looking back at the notes, addition is going to turn into multiplication. So addition is going to turn into multiplication, and we are going to have ln of x cubed y. Can we simplify any further? No. So is that our answer? Yes. Okay, so be careful. I use parentheses just so that it's very clear what ln is applying, but be careful. You don't want to select the answer that says xy cubed because the cube is only applying itself to the x, not the y. So make sure the answer is just x cubed y. All right, smash it a little bit. All right, going on to number 3. Number 3 is the one I was talking about with the fractioned exponent and whatnot. So I kind of broke it down the first step for you. So if you see here, 1/4 ln 3 plus 1/4 ln x turned into ln 3 to the 1/4 plus ln x to the 1/4. So what did I do? Same thing as these, I'm just dealing with a fraction. What did I do? I took this big number and I applied it as an exponent. I took this big number and I applied it as an exponent. That's where these exponents came from. Now, what do fractioned exponents turn into? They turn into radicals. So again, numerator goes inside, denominator goes outside. So we have ln where the numerator goes inside, the denominator goes outside. Now since the numerator in this case is a 1, we don't need to write it. I'm just showing you so you know it just didn't vanish. Okay, same thing with the other side. ln, denominator goes outside, numerator goes inside. Now, works like normal, plus turns into multiplication. So we have ln of this times this. So ln of the 4th root of 3 times the 4th root of x. Since these match, we can put them together in the same radical. So our final answer should be ln of the 4th root 3x. Close parentheses. And done. So those are the first 3 problems. Those go over the natural log stuff. Just kind of the same fundamental rules that we did with logarithms. So now, question number 4. Let's start getting into how we actually solve these things. So number 4, I've already started the process for you. So we got to think, I want to get x by itself. what is the opposite of ln? So what cancels ln? Well, e cancels it. So what am I going to do? I'm going to apply e to this side. What I do to one side, I need to do to the other. So I applied e to both sides. Now, this will take out this, and we're left with x, and then I did nothing on this side. I just brought it down. So this is technically our answer. Now it wants us to approximate. That's what this fancy little equal sign means. It means to round. It means to get a decimal and give the gist of what that decimal was, right? So let's see what we get. So I'm using this type of a calculator. Most of your guys' calculators should be similar. To do this, we're going to type in 0.1 first, and then we're going to hit e to the x. So I need to hit 2 and then e to the x. And I'm going to get that decimal. Okay, so that is going to be our answer. So we are going to just say 1.1. If I were to round up, it doesn't do anything. 5 turns that into 1. 1 doesn't matter right there, so it's just 1.1. So hopefully this problem makes it very clear on how to do these, as it's the more simple version of these. Okay, let's go into one that's not so simple. Now, with this problem number 5, we're going to do the exact same steps as this problem. We're just going to have a few more. So again, I want to get this by itself. What's stopping it? ln. What is the opposite of ln? E. So what do I need to apply to this side? E. If I apply something to this side, I have to apply it to this side. So we should get e to the ln 3x minus 9 equals e to the 21. Now, after we have that, e will cancel out ln, and we just get 3x minus 9 equals e to the 21. I'm not dealing with that decimal just yet. I just wanted to bring it down and deal with this side first. So now, this side looks like a standard pre-algebra problem. This is just a decimal. So let's get this decimal and then solve this problem. So to get e to the 21, I'm going to type in 21, hit second, and apply e to it. Now I get this huge number. And while you're thinking to yourself, did I do this right? The last one was this simple little 1 point. Yes, you did it correctly. I don't know why they gave you such a large number for this. Okay, but just deal with it. We're going to continue. So I have 3x minus 9 equals 1, 3, 1, 8, 8, 1, 5, 7, 3, 4. So what is this? We have our thousands, millions. What is that? 1,318,815,734. Ridiculous, but not too terrible. So, what do we need to do? If this was just 13, what would our step be? We need to get x by itself, so we would get rid of that first. So what's the opposite of a negative 9? A positive 9. What we do to one side, we need to do the other. So just because it's a huge number, doesn't matter. Our steps are going to be the same. So I'm going to add 9 to both sides. Okay, so I have 3x, that cancels that, equals, and since I still have this number on my calculator, I can just add 9 to it. Save yourself some headache, right? And so there's my new answer. So I'm going to write this right here. 1, 3, 1, 8, 8, 1, 5, 7, 4, 3. Now to give me some more room, I'm just going to rewrite it up here. So 3x equals 1, 3, 1, 8, 8, 1, 5, 7, 4, 3. Whew, big number. Now, what's stopping x from being by itself? That 3. What is that 3 doing to x? Multiplying. What's the opposite of multiplication? Division. So if I want to get rid of it, I need to divide both sides by 3. That cancels that. And we have x equals this divided by 3. So notice, it's a good thing not to clear your calculators after every step. So I have x equals 4, 3, 9, 6, 0, 5, 2, 4, 7.8. Now that 0.8 is important, and you do need to type that into your Canvas answers. Okay, so on that little text box, make sure you type in that whole number. It should be 439,605,247.8. All right. Again, big numbers, but the steps here are fairly simple. Moving on to this one. Oh my gosh, Thompson, fractions. I don't want to deal with fractions. This looks so hard. It's not hard. It's the same type of problem as this. We just multiply. So don't worry. It's not that difficult. Take it one step at a time. I want this by itself. What's stopping it? That. What's the opposite of ln? E. So notice the steps are not changing on any of these problems. So I'm going to apply e to both sides. E to the ln of x plus 2 over 3 equals e to the 12. That's a 3. Now it's very hard. It'll get bigger soon. So e kills ln, and this comes down, and we just have x plus 2 over 3 equals e to the 12. So now, our next step is going to make that into a decimal or a number that we can actually deal with, okay? And then we will simplify that just as if it were Algebra 1 or pre-algebra again. Okay, so let's turn that into a real number. So we're dealing with E12, so we're going to type in the 12 first, hit second, e to the x, and there is our number. So I have x plus 2 divided by 3 equals, right here, 162,754.79. So it has 0.7914. I'm just going to round and leave it at 0.79, but I'm going to leave this in my calculator and just do my math from there, just so you guys can see it doesn't really matter. So now, what's stopping x from being by itself? What looks like the biggest headache? This 3. What is that 3 doing to this x plus 2? Dividing. What's the opposite of division? Multiplication. So if I want to get rid of this 3, I need to multiply both sides by 3. This 3 will cancel this 3, and I get x plus 2 equals this times 3. So this times 3, and I get that. So x plus 2 equals 4, 8, 8, 2, 6, 4.37. And then again, I'm just rounding. So now, just as if this was a normal number in pre-algebra, what's stopping x from being by itself? Plus 2. How do we get rid of the plus 2? Subtract. What we do to one side, we do to the other side. So again, I'm going to give us a little bit more room. Draw my fancy little arrow. Look how beautiful that arrow is. It's spectacular. Kind of looks like S for the greatest teacher of all time. So we have x plus 2 equals 4, 8, 8, 2, 6, 4.37. Just rewrote it to give us room. So now I'm going to subtract 2 from both sides. Notice that I wrote it over the ones place, not the decimals. Just be sure you don't accidentally mess up. So that cancels that, and I have x equals. If you don't want to worry about that, you can just not clear your calculator and just subtract 2 and get your answer. So we should have our answer as 488,262.37. Okay. Now they rounded in Canvas. They rounded this to the nearest 10th place. So our answer will be 488,262 point round up 4. So again, I hope I made this very clear. I'll leave these answers for a few seconds in case you guys needed time to, write them down, type them down. If you hadn't realized it by now, you could always pause the video and write things down if I am going too quickly. But please let me know if I continue to go too quickly for you guys. All right. Moving on to number 7. So, question number 7. Remember, 7, 8, and 9 on the notes, I said that we are going to do the same thing that we've been doing, but we're going to go backwards. So what's the opposite of an E? What's the opposite of E? ln. So if I want to get rid of E, I apply ln to both sides. So number 7, I've already done for you. Let me walk you through the steps. So e to the x plus 1 equals 30. I want to get rid of e, so I apply ln to both sides. This cancels this, and I just get x plus 1. I just brought the exponent down. ln 30 I just brought down. Now, just like before, I turned this into a decimal first. I type that into the calculator. To do so, I just have ln here. So I type in 30 first, hit ln, and it'll already work. So 3.401, 3.401. Okay, now just like normal, x plus 1 equals 3.401. What's stopping x from being by itself? This plus 1. What's the opposite of plus 1? Minus 1. What I do to one side, I need to do to the other. So that cancels that, and I'm left with x equals 2.401. So that is what you're going to be typing into Canvas. Again, I wrote this one really clearly, hopefully, and I even wrote some pretty beautiful 3s. So use this as your little template, as your example to go back and forth to on your practice so that you know how to do these problems. All right, let's look at number 8. I wrote my equal signs exactly how you guys should be writing your equal signs so that they are perfectly vertical, okay? So let's continue. Step 1. This isn't by itself. This is stopping it from being by itself. So I need to get rid of this first. And what's the opposite of a positive 0.72? You guessed it, negative 7.2. What I do to one side, I need to do to the other. That cancels that. And we're left with e to the 2x over 5 exponent. That cancels that. And just so that you guys stop making simple mistakes, 9.1 minus 9.1 minus 7.2 is 1.9. If you need to type the stuff into the calculator, do so. I want you to understand the concept and not get messed up when you're just adding and subtracting decimals or negative numbers. So if you need to use a calculator, do not be ashamed, just do it. Okay, 1.9. Now, just like this problem, what's the opposite of e? ln. So if I want to get rid of e, apply ln to both sides. So I have ln e to the 2x over 5 and ln of 1.9. Now, this cancels this, and I have 2x, whoops, just scratch out this line. So I have 2x over 5, ln 1.9. So far, so good. Remember, the exponent just becomes big, and we're good to go. Now, before I can start simplifying this side, I'm going to turn this into a number. So I'm going to bring this straight down and get 2x over 5 equals 1.9 ln, which is 0.642. 0.642. Now, I'm going to draw my almost perfect, you can ignore that, my almost perfect arrow, and just give us some more room up here. So again, I just rewrote it to give us more room. I didn't change anything yet. All right, what's stopping x from being by itself? This 2 and this 5. What's this 5 doing to x? Dividing. So how do we get rid of it? Multiply. So if I want to get rid of it, I'm going to multiply both sides by 5. This will cancel this, and I'm left with 2x equals this times 5. So this times 5, and it gives us 3.21. Now what do we do? Get rid of this 2. How do we do it? By dividing. What I do to one side, I need to do the other, so that will kill that. And we have x equals this divided by 2, 1.60. So 1.6046, or as we round up, x equals 1.605. And that's what you will be typing into your Canvas box. So again, I hope that made sense. Okay. And now let's move on to the last problem on the homework, on this lesson. So as you can tell, I make tons of mistakes. So just bear with me here. This is not number 9. This is the little box you guys usually ignore that happens right before number 9. So let me go over it quickly, and then we will do number 9 together. So for number 9, and this gray box problem, this example problem, we're going to use this formula. A equals PERT. That's what helps me remember. Where A is the total after all of the rate and interest and time has passed and been applied. Okay, so expect there to be decimals and the number to not be that clean. P is the principal, so expect that number to usually be the clean number. Then we have R, which is rate. You're always going to use it in decimal form. And then T is always going to be time. In this gray problem, time is what we're solving for. In number 9, the rate is what we're solving for. The steps do not change. So just be careful with this. So here we go. I used direct substitution. Well, they did in the gray box. I'm pointing there because that's where my computer is. So what I did is I plugged in 149.18 for A, 100 for P, E I left alone, 0.08 for R, and T is what I'm solving for. I got rid of this 100 first so that I could solve for E, right? So I divided 100 on both sides, which made me move the decimal. Then what did I do? I applied ln to both sides, which canceled out this, and this gave me a decimal after typing it into the calculator. Then what did I do? I brought my exponent down. Now I divide both sides by 0.08, and I got about 5 years for my t. Okay, so again, all of those steps, I know I went quickly, those steps are in the gray box. That is not the problem we're actually trying to solve for. I just wanted to briefly go over it so that you could kind of see it and it be familiar before we get into it. So now, as we look at number 9, as we read the problem, it says an initial investment of $200. So right off the bat, I know my principal is 200. Notice it's a clean number. It is worth 315.24 after everything is said and done. So I knew after the interest was applied and after time has passed, that's what I had in my account. So that was my A. After 7 years, so I knew t was 7, and it says solve for r. What is the rate? Find the interest rate. So I took out these numbers, I plugged them into this formula, and this is what I've gotten so far. So I plugged in 315.24 for A, 200 for E, or 200 for P. E stayed the same, R stayed the same because that's what we're solving for, and T turned into 7. So step 1, we need to get this by itself, so I need to get rid of this. So what's the opposite of multiplication? Division. What I do to one side, I need to do to the other side. So 315.24 divided by 200 equals 1.5762. 1.5762 equals e to the r times 7. Now I need to get rid of e to solve for r. So what's the opposite of e? ln. So I need to apply ln to the right side. But what I apply to one side, I better apply to the other side. One side to the other side. English is hard. 1.5762. Little smashed right there. I'm writing on a counter, so there's grooves in my counter. All right. Who am I joking? My handwriting's bad anyways. So now I'm going to type this into a calculator. Okay, so I'm going to type in 1.5762, and I'm going to apply ln to it and get 0.4 or 0.4550168887. So just for time's sake, I'm just going to write 0.455. 0.455 equals, now notice, those cancel each other. That is all that I'm left with. So r times 7. So we have r times 7 right here. What's stopping r from being by itself? 7. What is it doing? Multiplying. What's the opposite of multiplication? Division. What I do to one side, I do to the other. So now I have r all by itself. Type that into my calculator, and I have my answer. So I already had it still before I simplified. Now I'm just going to divide by 7. And I'm going to get 0.65. So 0.065, or as a percentage, what would that be? R equals, move the decimal over twice to get my percentage, 6.5%. So I hope that made sense. I hope that's clear for you guys. Okay. Again, the whole point of this problem is to really get you guys used to swapping out L and N and canceling each other out. All right, so I'll bring back the notes to this video. You guys can look at them. You can take a screenshot, take a picture, write them down. You can always resort back to this video if you need to. Just try your best with these. They shouldn't be terribly difficult, but if they are, feel free to email me. Otherwise, you can join me every Tuesday from 10 to 12 in tutoring. I hope you had a great time watching the video. I hope you enjoyed Party Dog, and I will see you next time for another Algebra 2 lesson. Take it easy.